All right, moving along with with looking at the differences between additive manufacturing and CNC is we're going to look at some of the complexity of the parts in which each one can make. So CNC loses geometry on a single part. Okay, you're not able to, on one single milling process, you're not able to mill the single part or have as complex of geometry as you would with an additive manufacturing. The tool just can't reach some points, okay? You know, like on this glass, okay? Some of these points along here, because of the angle in which the tool is coming down, it can't hit some of these without removing too much. And so, because you got to remember, a tool will come up and down. A tool can't come in at this angle, okay? And that's where the complexity, in addition to, if we think about this as a bottle, it's rounded here and then it's rounded in the other direction. And so it cannot move in those three directions to be able to make this part. Some parts cannot be fabricated using a single component. What it's saying is like the idea of the ship in the bottle. You cannot make a ship in the bottle using a single process, CNC. You would have to come in and mill out parts of the ship, assemble them, and then assemble them in the bottle after you've made the bottle. But the way the CNC works is, I'm not sure you can make the bottle in a CNC just because you can't get the tool inside here to mill out these because it cannot bend and do these corners and these axes. It has to be made of multiple and then have a assembled post machining. So then you're coming back in, you're inserting the ship, maybe inserting the ship in pieces to reassemble. Okay, ships in a bottle. This cannot be made from a CNC process. Where advanced manufacturing doesn't have as many constraints and is built from the bottom up instead of the top down. And so you're able to build the ship in the bottle, okay? Because it can reach different materials, okay? It can reach different layers, okay? Because it's going to go through and it's going to lay down the bottom and it's going to lay down the top on top of it. And so you're going to build the structure on top of it and leave these voids there along the way. And so the idea, the additive manufacturing has a lot more capability within the complexity of the geometry. Okay, accuracy. Okay, the positioning resolution is dependent on the cutting tool and the radius of the internal corners. So depending on what type of mill and the flutes on the mill will change how the resolution on the part. Now I will tell you, CNC milling can create very accurate, very precise, and don't take me that they don't make accurate, precise, or even beautiful pieces, okay? But when you're coming down to specifics and comparing the two, some of the issues come back because of resolution along the way. Where if we go and we look at the accuracy of parts, okay, they can be within a few microns of each other. So the additive manufacturing, so the different resolutions can have different resolutions along the different axes. So if we know an additive manufacturing machine, okay, I gotta orientate my hand just right. Okay, this is positive X, positive Y, positive Z. Okay, if you orientate it just right, the build axis is lower, okay, has a lower resolution because maybe there was a little tiny air bubble in there. And so the material that you're using isn't as we talked about being homogenized. The material isn't as good, okay? The material that you're using isn't as good, so your resolution isn't as high. Some machines have even higher, okay? Some machines have any higher, like a stereolithography machine, such as this one, because they're using the light to solidify it. And then the excess material, the excessive materials then recycled and put back in. So accuracy could be higher on an additive manufacturing machine than a CNC. Okay. The geometry of the parts. Okay. The geometry of the parts also play a role. And I purposely pulled out the geometry of this. You cannot make this shape on a single part, okay? You cannot. I'm not sure you can actually make this shape in CNC, or it would be very, very difficult. Because here's one thing that you need to understand is the top rim is inside the bottom, so the bottom is wider than the top. So how do you, if you're going to CNC this teacup, and this starts from a solid block, how do you get in here at that angle to mill around in a circular manner the bottom on the inside? I'm not sure you can get a tool in there where you can't. These surface points are just, these profiles are just too radical to be able to achieve that, especially on the inside. You know, you would lose, you could also possibly mess up around here. I think you could, if you started with this already having a void inside, you could then come out and mill the rest, but you would have issues creating the inside of this part along the way. But on the flip side, if we talk about additive manufacturing, this is not a problem whatsoever, because we're going to start down here and we're only going to put in the layers that we need. Okay, and so you're going to use these bottom materials as stabilizing material along the way to help support the part. The same as up here. You're going to have support be added that's easily removed to create the geometry of this part. Okay, next you have programming. Programming is the last part of the comparison. So CNC, okay, is highly involved within the programming. You have to select the tool, machine speeds, approach settings, angle, and it can be dangerous. So you can let the computer decide some, but if somewhere along the way, the designer has to select what tool is he going to use. Is he going to use a ball end, a flat end? What kind of milling tool is he using? How many flute? What type of tip does it have? Because all of them play different roles into how fast you can, how fast your spindle and how fast it rotates to make the part. Okay, the machine speeds. Okay, changing parts, changing materials. If you know them, you know different materials. You either speed up or slow down. Speed up or slow down based on other aspects of it. Plus, you go to approach settings. Okay, as you move from if you have a piece here and your tool's up here, how fast you come down is different than how fast you go here, and that it's going to safely make this move. But if you have a high amount of going to try to make a lot of parts, this is waste of time. You want the tool to get from here to here as quickly as you can. Okay, CNC is also highly involved because it moves. The tool moves X, Y, and Z. Okay, And what happens is that if you have to come in here and maybe get a beveled edge, that beveled edge, you may be able to come around and get it like that. But if you have a highly angular edge, you have to change your maybe change your angle of your piece before you can move your tool. This picture here is a prime example of the dangers that can be CNC. Okay, the dangers that can be CNC. So the CNC, if you don't set things up, you can actually really hurt tools and machines. So my understanding, what I'm viewing at is this is, so this is the build plate on the CNC. So they're trying to mill a piece, okay, with different 4 holes and 2 slots. But this is the plate. This is part of the CNC machine. And so because they've had a Z-axis failure, plunging too far into the machine, they are now ruining their own machine and have to replace this because the person didn't set 0 right. Now on the additive manufacturing machine, that won't happen because you don't tell it where 0 is, it finds it itself. Okay? It's not nearly involved because all you're doing is you're selecting the layer thickness, the part location, okay, within the 3D space where the part is being made, maybe the orientation of it, material color, and you hit go, and it does the rest. That's already pre-planned in it. In a lot of cases, the worst thing that can occur within an additive manufacturing environment is your part just fails. Your machine doesn't break because you didn't set up Z right. Your part just fails. So you pull it out, check a few settings, and roll again. And so that's some of the differences between CNC and additive manufacturing.